In exercises 17 to 42, we want to find a number of things. We want to find the critical numbers, if any. Then we want to find the open intervals on which the function is increasing or decreasing. We want to apply the first derivative test to identify all relative extrema. And we'll talk about the first derivative test in the context of the problems as we do them. You'll see they're very simple. It's a very simple idea, and we have alluded to it already in the past. And then we'll use a graphing utility to confirm the results. Alright, so let's get started. First problem, we'll do the odds here, and you should really try the even ones. Number 17, f of x is equal to x squared minus 4x. F prime of x then is 2x minus 4. We want to set that equal to 0. 2x minus 4 equals 0. Then we know that x has to equal 2. So that's our critical number there. Now, we want to determine where the function, intervals on which the function is increasing or decreasing. So we make our number line. We have only one critical number, and we're working with the first derivative function. Now we need a test value to the left of 2. 0 is great. 3 to the right. And we have to remember that we're plugging values back into the first derivative because we want to see whether the first derivative is positive or negative on these intervals. Plug in 0, we get negative. Plug in 3, we get positive. And so we know then that the function is decreasing. Hang on one second. And before I do that, I will draw these arrows here to show that the function was decreasing from negative infinity to 2, increasing from 2 to positive infinity, and that we have a relative minimum at x equals 2, and we'll see how to find the y value that goes with that in a second. Alright, so we'll write in here decreasing from negative infinity to 2. It is increasing from 2 to positive infinity. Now, this problem talked about the first derivative test. Well, here's where we use the first derivative test. Notice that when the function's derivative goes from negative to positive, the function goes from decreasing to increasing, and we get a relative minimum at that point. That's all the first derivative test means. You use the first derivative test if it changes from negative to positive. That indicates a relative minimum. We'll see later that if it changes from positive to negative, that will indicate a relative maximum. And if it doesn't change signs, then there is no relative extrema at all there. Alright, so we're done with number 17, except for one thing. We need to find the y value of the relative min. So how would we do that? For this case, we need to plug back into the original function because we want to find the y value that goes with x equals 2. And so in that case, we'll get 4 minus 8, which is negative 4. Now, if we were to take the graphing calculator and I enter the function x squared minus 4x, and I zoom standard, and I get a picture of the graph, and I can see that it definitely appears to be decreasing from negative infinity to 2. And I can actually find the minimum value. I'll go second calc and 3. For minimum, I need a left bound, just any point to the left of the peak, the low point there. Then I need a right bound, any point to the right of the minimum and a guess, just hit enter, and it finds it at 1.999, which is essentially 2, and negative 4, which is what we have here. So I will save a copy of that and we'll go on. Alright, next we'll take a look at number 19. So 19 starts out with negative 2x squared plus 4x plus 3. First thing we need is the derivative. Sorry. Need to label that as f of x. So the first thing we need is f prime of x. And we get negative 4x plus 4. We want to set that equal to 0. Negative 4x plus 4 equals 0 when 4x is equal to 4 or x is equal to 1. That's our only critical number in this case. We're going to make our number line, and it's when you have a quadratic function, all quadratic functions make parabolas, and so there will always be only one critical number with any parabola or with any quadratic function. It will either be a minimum or a maximum. In this case, because the leading coefficient of x squared, or the coefficient of x squared is negative, it's going to be upside down. Alright, so we label our one critical number, and we're working with f prime of x here. So we need test values. 0 and 2 work fine. Again, we have to remember we're doing the first derivative test here, so we are working with the first derivative. Plug in 0, we get positive. Plug in 2, we get negative. And so we see positive slope, negative slope, and so there is a relative minimum. When the first derivative changes from positive to negative, that indicates a relative maximum, I should say. And that is what the first derivative test means. You're looking for the change in derivative from positive to negative, maximum, or from negative to positive, minimum. And that occurs at 1. But to find the y coordinate that goes with that x coordinate, we have to go back to the original function. So we're plugging in a 1 there, and we get negative 2 plus 4, which is positive 2, plus 3, which is 5, appears to be 5. Alright, so I think we have all the information we need here. The function is increasing from negative infinity to 1. It's decreasing from 1 to positive infinity. We found the relative maximum and we found the critical numbers. Now let's go and use the calculator to just double check this. So we're going to put in our original function, negative 2x squared plus 4x plus 3. We zoom standard and we get a shape that looks like what we had. We need to find out where that maximum is. We go to option 4 for maximum and select a point to the left, select a point to the right, then hit enter for guess, and we get at 1 and 5, so we were accurate there. I'll take a picture and leave this in the file. And so hopefully that process is clear. Not too difficult. We did a lot of things there. We found where the function is increasing, decreasing. We found critical numbers. We found relative min and max. And we verified that all with the graphing calculator. So we'll stop this video at this point.